What do we do there, Jasmine? What do we do there, Lucas? X minus 4 squared. Right, Connor? That'd be a good thing to put in the public chat, Connor. Connor's saying we need to write it twice. Okay. What do we not? Oh, you did make one mistake, Connor. You made a pretty common mistake there too, right? You wrote a plus. I remember squaring means multiplying something by itself twice. Okay, so make sure you don't put that plus sign. Okay. So remember what it doesn't mean is that you're not allowed to do this. Okay, that's not okay. You need to go through and write it out twice, and then go through and do the foiling. X times x is x squared. X times -4 is -4x. -4 times x. -4 times -4 is positive 16. So we get x squared minus 8x plus 16. Okay, that's the appropriate way to do that. Something we've talked about before, something you would have seen in Algebra 1 also. I'm not going to do number 2. I'll do number 3 and 4 here. We're going to be doing some more factoring today, so I just want to bring that back, warm that up on you guys. Okay? You see 3 terms. You should be thinking about your AC method. Okay? So what's my A value? What's my C value? A is 1, C is -40. So my AC is -40, 1 times -40. I need those factors of -40 to add to 3. So Brooklyn, what factors of -40 would add to 3? Or Elijah, what factors of -40 would add to 3? Good, Jacob. 8, -5. So we get x squared plus 8x minus 5x minus 40. Let's break that. First two both have an x in them. Times x plus 8. That third term is a negative, so we need to take out a negative, and 40 and 5 both have 5 in them. And -5 times x and -5 times positive 8. And remember, don't force this to be the same, but they do need to be the same. It's supposed to happen on its own. If this isn't happening on its own, that's letting you know that you made a mistake somewhere. Got your signs wrong, you used the wrong pair of factors. Okay? But if you fudge your way through that, it's not going to show you that you're making a mistake. So there's my factorization, right? Remember, factoring is undistributing. Right? Here we distributed, we ended up with a standard form quadratic. Take that standard form quadratic and we factor to get to a distribution problem. Okay? So these two processes are inverses. They undo each other. You should end up with 2 sets of parentheses when you're doing this. Same starting spot on 4. That's my A times my C. 1 times 24 is 24. We need 24 to give us -14. Bella, Maya, what would be our factors of 24 that would add to be -14? Almost. -12, -2. Okay. So we got x squared minus 12x minus 2x plus 24. Break it. We can do GCFs. So x times x minus 12. And the next two have a 2 in them, but it needs to be a -2. -2 times x and -2 times -12. Check to see that those are the same. They are, so then we can move on. X minus 12 and x minus 2. Okay. We're going to be doing factoring today. We're going to be doing this expansion of the binomial today. Okay? Something you just need to be on board with. Skills that aren't going away. Anything you guys need to talk about there before we move on? Okay. Thanks, Del. You guys good? All right, here's our first problem. We're going to be solving and checking. Okay. Really, if you think about the steps we did yesterday, they're really pretty much the same. We won't be doing any rational exponent problems today. It'll be all about the radical stuff. So if you think about what, our first step there yesterday was to isolate the radical. If there happened to be a number over here, like if it said the square root of x, 60x plus 256, like plus 2, then our first step would be to kick the 2 over before we go further, right? I don't think you guys are going to see any problems like that, but same thing as yesterday. We want to isolate the radical first. Okay. In this case, the radical is already isolated because as we look at that left side, or that right side, sorry, there's nothing on the outside of that. Okay? So radical isolated, check. All right. Step 2, how do we get rid of a radical? All right. By looking at the index, this is an index of 2. So we would raise both sides to the second power. Square roots, we square to get rid of square roots. Cube roots, we raise both sides to the third power. We cube both sides. Okay, so it's still that same idea. How do I get rid of a root? By raising both sides to the power of the index. Right, and then step 3, once that's gone, we're going to solve. So for solve is a pretty big word. We have lots of different ways of solving equations, and today's going to be a little bit broader. Are we going to need to solve, like get x by itself, or are we going to need to factor to solve? Those are things we need to be considering. Don't need to do step 1, so we're going to move to step 2, which is we're going to square both sides to get rid of that square root. Of course, we look at that left side, x squared just means x squared. We look at the right side, right? Why did we square? We squared to cancel the radical, so it's gone. So we're left with 60x plus 256. So step 1, didn't have to do it. Step 2 is done. Step 3, solving. How do we solve an equation like this? What do we have to pay attention to? What I need to pay attention to here is that there are different types of x. I can't get x by itself because there's different types of x. How do we approach it then? We solve it by factoring. And when we solve by factoring, we have to get one side to be 0. And we've spent time doing that. This shouldn't be new to you guys. So we're going to move everything towards the x squared. That was definitely something I saw on Tuesday that I wasn't very happy about from those of you guys that did the homework. How do you deal with that? Okay? You should always move stuff to make the x squared positive, or have the x squared be positive, not the other way around. Some of the stuff I saw coming back was you guys doing it a different way. It was certainly nothing I ever showed you to do it that way. Okay? So both of these need to head to the left. So I'm going to subtract 60x over. I'm going to subtract 256 over. Okay? That gives me x squared minus 60x minus 256 equals 0. Make sure you have an equation that's equal to 0. Should be looking at that and saying, oh, I can just do some AC method on that. All right, well, what's my AC? 1 times negative 256. So. And that needs to add to negative 60. I'm not too familiar with my factors of 256. So I need to start burning through this, right? How do I figure it out? Well, what's 1 times 256? Can't get 60 out of that. What about 2? Is 2 going to 256? 256 divided by 2, 128 times. That's not going to give me 60. What about 3? 256 divided by 3. Nope. 4. 256 divided by 4. 64. Oh, there's a 60. 64. I need negative 256, so one of those has to be negative, and I need negative 60, so it must be the negative 64. Negative 64 plus 4 is negative 60. Negative 64 times 4 is negative 256. All right, so there's my numbers. Make sure it still says equals 0. Okay? So the point of this, we've taken that negative 60 and we've broken it in a special way, a unique way, so that it still equals negative 60, but now we are going to get that negative 256 out of it. Once you break it again, okay? You go looking for common factors. First two have an x times negative 64. And then the next two both have 4 in them. And you need to make sure you write plus 4. Too many of you guys are leaving off this plus sign right here. That's something I've always asked you guys to make sure is there. Taking out a positive 4, it better say positive 4 there. 4 times x, 256 divided by 4, we just did that, 64. Check to make sure that those things in the parentheses are equal. They are, so I bring them together. Then we have x plus 4 comes together. We're done factoring. And nothing inside the parentheses is common. There's no more higher powers. We're done factoring. Remember, the last step technically is you're supposed to write x minus 64 equals 0, and you're supposed to write x plus 4 equals 0. But we've done this enough to recognize that, oh, all I really have to do is switch the sign. X equals 64, and x equals negative 4. Okay? So there's our supposed answers. Okay? So what we do is we need to go and check those. Just like we talked about yesterday, we need to check both those. You always check back in the original equation. Okay? Which again, I saw you guys doing a good job of that yesterday. Just not doing a good job of, not everybody was doing a good job of checking correctly after that. Doesn't matter which one you do first. Let's grab the first one there, 64. Go back to my original equation. So I see x equals, so 64 equals square root of 60 times 64 plus 256. Be a big number over there. Of course, the left side is just going to stay 64. 60 times 64, 3840. That's the first thing I did was that. Plus 256. I'm going to do that. It's 3840 plus 256. It's 4096. So I'm hoping the square root of that is 64. So square root, that thing, 64. Sweet. So 64 equals 64. Check. So 64 works. Let's check negative 4. So negative 4 equals, that was what, square root of 60 times x, so negative 4 plus 256. Start in the same place, I need to multiply first. That gives me negative 4 on the left, square root of negative 240. That's 256. Do my addition here. Negative 4 on the left, square root of 16. Negative 4 equals 4. So there's our extraneous solution. Okay? You don't always have an extraneous solution, but you can. How we know it's extraneous versus being wrong is that it's just that sign that's off. Right? It's 4 versus -4. It's not -4 equals 7. And it's not -4 equals 0. That would be telling you that something is wrong. That sign is off. So we didn't do anything wrong. It just happens. Again, that was a big thing from Tuesday, was that idea that when we square both sides, we're creating a place for something to go wrong. Because when we square 4, we get 16. When we square -4, we also get 16. But when we square root 16, we only get 4. Because that's not reversible. Okay? Remember, we didn't put that square root there. They did. So it's not a plus-minus issue. When you do x squared equals 25, and you go and square root, we decide, oh, I'm going to square root to solve this, that's when the plus-minus jumps in. Okay? Because there's 2 answers to that equation. So we didn't put that square root in, so we don't do the plus-minus. We just do the positive version. That's why it doesn't work. So we label that as extraneous. You don't erase it, you don't ignore it, you don't scratch it out, you label it as what it is. Okay. Here's the answer I got. I know it doesn't work. It's not because I messed something up. It just happens sometimes. But if you get 2 completely different numbers here, guys, you need to stop and say, what am I doing wrong? And it's not that you're going to be able to figure that out all the time, but you need to ask, what am I doing wrong? That's where you come and talk to me. Okay? I know this isn't right. Okay? Instead of just labeling extraneous, that's the last thing I want to see is you label a wrong answer extraneous. It's not okay. But it's a big problem, right? A lot of stuff. That was a lot of work. Okay? And the problems that you guys did last night was a lot of work. Anything you guys want to talk about here before we move on to the next one? So these next 2 actually look kind of rough. They're actually going to be the easiest ones we do. Okay. I'm going to change this real quick. Make that a minus sign there and equals 0. Okay. So I just want to show you what this looks like because you guys do have a problem that looks like this in your homework, so I don't want you to be too confused because I don't have an example that looks like it otherwise. So that first step is to isolate the radical. So what if the radicals are both on the same side? We would isolate them by just separating them. So our first step is just going to be to grab that and move it to the other side. Okay? So if they're on the same side, just separate them so there's 1 on each side. That's what makes it easier to deal with. Okay? And then we go back to our original equation at that point. Okay? If you see that, just move 1 to the other side. Okay? Just make sure my radical gets across there. There were a couple of you guys saw that you struggled on a problem because you didn't write the problem down correctly. You brought something that wasn't supposed to be in the radical into the radical, or you didn't make your radical long enough. Little things like that. Handwriting issues can certainly mess up the problem. That's just a minus sign, Peyton. The square root of x plus 1 minus the square root of 3x plus 1 equals 0. I just added this to the other side. All right, now I have a radical on both sides. So how do I get rid of a radical? I raise it to its index power. Those are both square roots. So I just square both sides. Well, what happens when I square a square root? They cancel. So those all go away. We're left with x plus 1 equals 3x plus 1. All right, so this is why I was saying this is actually easier, because when you look at this, you notice that the x's are the same type of x. Right? We don't have x's and x squared, we just have x's, which means we just go back to our old solving techniques that you've known for years and say, oh, I'm just going to subtract x to the right side, I'm going to add subtract 1 to the left side, that cancels, I get 0 equals 2x. Oh, well, that means x is 0. That was easy. All right, so this is why I was saying this is actually easier, because when you look at this, you notice that the x's are the same type of x. Right? We don't have x's and x squared, we just have x's, which means we just go back to our old solving techniques that you've known for years and say, oh, I'm just going to subtract x to the right side, I'm going to add x to the left side, that cancels, that cancels. So when you don't have squares in the problem, it makes the problems much easier to solve. So let me check 0. So if I use my original equation, the one that I changed, so my new original equation, so 0 plus 1 minus square root of 3 times 0 plus 1 equals 0. It's really horrible handwriting. So of course 0 plus 1 is 1, so square root of 1. 3 times 0 is 0, plus 1 is 1, so square root of 1. Even if I didn't know what the square root of 1 is, which we do, we know it's 1 minus 1. Even if we didn't know, if it said like the square root of 3 minus the square root of 3, right? Something minus itself has to be 0. So even if you don't know what that number is, you still know that it minus itself is going to be 0. So if it says the square root of 3 minus the square root of 3 equals 0, great. It says the square root of 7 minus the square root of 7 is 0, great. Okay? You don't have to know the value of the number to know that subtracting it from itself is going to give you 0. 0 works. Okay? Anything there on 2? Good? Okay. Again, because we have a radical on both sides, and you look at what's under the radicals, there's no squares or anything, this is actually going to be a pretty easy problem. Okay? The radicals are already isolated from each other, one on each side. So we just need to focus on getting rid of that radical, which means we're going to cube both sides to get rid of a cube root. That cancels, right? So 10x minus 5 equals 8x plus 3. Easy peasy, pre-algebra, algebra 1 equation to solve, right? No biggie. Subtract 8x, add 5. Two x equals 8. X must be 4. And then we check. I talked to you guys about enrollment yesterday, right? And if you need one-on-one conversation about what class you should be taking next semester or next year, just hit me up, okay? Let me know you need help. So the cube root, 10 times 4 is 40, minus 5, that's the cube root of 35, whatever the heck that is. Cube root of 32 plus 3, which is cube root of 35. And I have no idea what the cube root of 35 is, but I know it's equal to itself. Okay? You don't need to know the value of the number to see that it's equal to itself. You don't need to figure out what that is. Okay? If it said the cube root of 8, I would do that. If it said the cube root of 27, I would do that. It doesn't. It says something that we don't have a value for. So let's just move on. Okay? We could try to sock it out. It's not going to do anything. Okay? But we know that our answer works. Okay? What's kind of interesting is to think about what are we actually doing here. Right? Another way to solve this problem would be to solve it by graphing. I could ask you guys to graph these. We've done stuff similar to that, right? Cube root graphs. But what happens when we graph that? What happens when we say, the graph of the cube root of x, 10x minus 5, and we compare that to the graph of 8x, cube root of 8x plus 2? There's no cube root button here, so that for me to do that in Desmos, I have to do it this way. I raise it to the 1/3 power, right? That's what a cube root is the 1/3 power. So there's my cube root graph, right? It's that extended S. Okay. The other one was, what, 8x plus 3? Is that what it was? Plus 3? Cube root of that. So then to the 1/3 power. What did we find, right? Our answer was 4. Why is the answer 4? Because that's where the graphs cross. That's where the graphs intersect. Right? When we solve an equation, we really are finding the point where two graphs are crossing, whether they're lines or whether they're curves. We're finding the point or points where they cross. And we can see that these graphs cross at 4 and then 3.271. I'm guessing 3.271 is the cube root of 35. Okay? That's what we're doing here. We're finding that point where those graphs meet. So that visual connection. This is something you guys have done back in semester 1. We talked about, solving by graphing, finding those intersection points. Okay? Just kind of bringing that back. What are we up to here? How it kind of makes sense of things. Anything on 2 or 3 you guys want to talk about? Examples 4 and 5 really are the big ones here. This is going to be like what you guys did on Tuesday, those of you that did that assignment. Watched that video and did that one problem I asked you to do. Okay. It's going to be more similar to the first problem because notice how we don't have a radical on both sides. Okay. So when we, again, that isolating idea, if it had said this, if that 1 was here, you guys won't see problems like this. There's already enough to do, but just if, the first thing you would do would be to kick the 1 over. Okay. So let's get it to the other side so that it's away from the radical. So the radical is already isolated. So what we need to focus on is getting the radical getting rid of the radical. Right? And it's a square root, so we're going to square that. If I do that to one side, I have to do it to the other. And just like we talked about in the warm-up, how do we do x plus 1 square correctly? Okay? So on the right side, it's easy. It's just 7x plus 15. That right side means x plus 1 times x plus 1. Then we need to go and figure out what that's equal to. So we're going to do our FOIL, or you're going to do your distribution, whatever you want to call it. That's x squared times 1 is 1x, times 1 is 1x, and 1 times 1, of course, is 1. Simplify that in the middle. We got 2 x's there in the middle. That 7x plus 15 has just been patient, waiting for us to figure that out. Now it's back. Okay. And right now, the little light in your head going off. I've got 2 different x's. I got 2 different x's. Okay. I can't gather them, separate them from the numbers. I need to gather everything to one side. I need to be factoring here in order to solve this. That square there is saying, hold your horses, right? Always move it towards the x squared to keep it positive. And I saw some people doing some weird stuff on Tuesday where they're moving it the other way. I wasn't too happy about that. Always move it towards the x squared. We get x squared minus 5x minus 14 equals 0. Make sure that says equals 0. This is an equation you're trying to solve. And you're like, oh, okay, let's do some AC method on there. None of the factoring you guys are doing today should be, shouldn't be high level factoring. It should be some pretty easy AC method factoring. A times my C is negative 14. Negative 14 to give me negative 5. So Natalie, what would our factors of negative 14 that give me negative 5 be? Close. We need negative 14 and negative 5, Natalie. So that would be, what's 7 plus negative 2? There you go. Yeah. So we need negative 7 and positive 2 to get the negative 5. So x squared minus 7x plus 2x minus 14 still equal to 0. Don't lose that. Break it in half. First two both have an x times x times negative 7. Second two are both divisible by 2, and it's positive 2. That plus sign needs to be there. 2 times x, 2 times negative 7. You stop and you check. Okay, x minus 7, x minus 7. Sweet, I'm doing good. Little happy face goes off in your head. A little endorphin rush. X minus 7, x plus 2. You do that quick solve. Okay, x must be positive 7. X must be negative 2. All right, just flip that sign on those simple ones. Haven't seen them. Anything here on the solving before we do our check? Or our checks? How you doing, Elijah? How you doing, Chad? You guys good? Chad? Brooklyn? Nick to Brooklyn? I'm going to assume Elijah and Chad are asleep then. Okay. Oh, he's awake. All right. So grab one of your answers, go back to the very top, right? I'm going to check 7 first, just because it's there. It says x plus 1, so that's 7 plus 1. Square root of 7 times 7 plus 15. Nothing comes across the equal sign. We purely simplify down. 7 plus 1 is 8. That 8 is not going to change for the rest of the problem. 7 times 7 is 49. Plus 15. 49 plus 15 is 64. Ooh, that's good. Because 8 is equal to 8. Just because one works does not mean the other one won't work. You can have two answers that both work. Remember, what you're doing is you're finding points where these graphs are crossing. These curves can hit lines multiple times. That's fine. You can have 2 points that work. You can have one that works and one that doesn't. There's a really good chance for the problems that we do, okay, in this class, if both of your answers don't work, you're doing something wrong. We saw that yesterday in the notes that we had one answer, it didn't work. We said there's no solutions. Okay? I'm just letting you know from all the years that I've taught this class, for the problems that we do, if both your answers aren't working, you're doing something wrong. Okay? At least one of them should work, if not both of them. There are problems like this that don't have answers. We just don't do them. So, check negative 2. What was the problem? So it was negative 2 plus 1 equals the square root of 7 times negative 2 plus 15. You simplify only. Negative 2 plus 1 is negative 1. That's not good. This gives me negative 14 plus 15. Negative 14 plus 15 is 1. Square root of 1 is 1, not negative 1. And there's our sign issue. Okay? If the sign was different, we would have been good to go. Right? It doesn't say negative 1 equals 5. It doesn't say negative 1 equals 0. Only the sign is off. That's saying, hey, all right, we didn't mess it up. It's just that when we squared, it made everything positive, and then when we try to go backwards, it doesn't turn negative again. Just not how squaring works. So it doesn't reverse, and so then it messes up sometimes. Okay? So it's only the sign that's off. So we label it as extraneous. Do expect to see you guys doing that, labeling. Circle your other one that you know works. Okay? This is the way your work should look, guys. And the amount of work that you should be doing on a problem like this. It's a lot of work. These are big problems. Okay? And I'm only giving you guys 5 to do for your homework. They're really good skills, right? Can I factor? Can I square a binomial correctly? Right? Can I check my work correctly? And can I problem solve? Right? Again, your real thing you should be walking out of this class knowing how to do, guys, is problem solve. And by that, I do not mean solve math problems. It's those logical steps. I see this. I'm in this situation. How do I get myself out of it? How do I do what I need to do to be successful here? I'm getting in a car accident. Okay, what do I need to do? What's my next step? What's my next step? Who do I need to call for help? Who do I need to ask questions to? Okay? When I see this going on in the math, what's my next step? How do I logically think through this to get out of this, right? Oh, I see an x squared and an x. Ooh, that means factoring. Oh, I just see two x's. Okay, I can solve this a different way. Right? Problem solving skills, thinking logically through something. That's what you really should be walking out of class with. The way I'm teaching you guys that is through math. How do I think through math, but still just mainly about thinking. Okay? So I want you guys to walk out of here being good is thinking. This is not something you're going to do in your day-to-day life. Okay? The math isn't. The thinking is. I have another example queued up if you guys want to see, or we can be done. I don't know if I asked you guys if you had any questions from yesterday. I was talking so much earlier. I don't know if I asked you guys that or not. What do you guys need? You want to do another example? Do you have questions from yesterday's homework? No opinions, you're all asleep. Need time to take a nap. Okay. And the daily point is in there. You guys you got 7 minutes. You can go work on that. It should not take you 7 minutes. Is that Ms. Barclay? Yes.
Is there homework?
Yes. It's in the Google class. It's also, let me share that again.